Welcome to Math Essential Vector Calculus. In this video, we'll discuss about scalar and vector fields. The purpose of this video is to understand what a scalar and vector field are, recognize them by various examples including temperature, pressure, and velocity, and set the foundation for important quantities in vector analysis including gradient, divergence, and curl. So the question comes here, what is a field? A field is a rule that assigns measurable quantity, either a number or a vector, to every point in space. We have two main types, scalar field and vector field. A scalar field assigns a single value to every point in space. Examples of this one is in electromagnetic, we have the electric potential. In fluid dynamics, we have the pressure, and in thermodynamics, we have the temperature. The value change with the position, but direction is not associated. Let's take example about temperature. Here, a distribution of temperature, high or low. So in two dimension here, at this specific point, for example, there is a specific value of temperature, and so on for different positions. On the other hand, a vector field assigns a vector which has both magnitude and direction to every point in space. In electromagnetic, this can be electric field or magnetic field. In fluid dynamics, this can be velocity of the flow, for example, flow of the water. In thermodynamics, the heat flux, we have the temperature, then due to the temperature difference, heat flux will flow. This will be represented as a magnitude and a direction as shown here. Now we move to the mathematical representation. In the case of a scalar field, it will be just a function. Of course, if it was in Cartesian coordinate, it will be function of x, y, z. At the end, once we substitute, we will get one value of this function. On the contrary, the vector field is a function which has components in the three coordinates. Of course, depending on the coordinate system, a1, a2, a3 can be I, j, k, or rho, phi, and z, or r, theta, and phi. At the end, we will have at each position, the field or the vector field will be defined by a value of magnitude and a direction. Let's wrap up this. A scalar and vector field describe how quantities vary and interact in space. For example, a potential difference, which is actually a scalar, can give rise to electric and magnetic fields, which are vectors. Another valid example, which may be much easier, if we have water in highland, here we have water, this means this water has high pressure. Due to this high pressure, which is actually a scalar, what will happen? We will start to have a flow as long as there is nothing blocking, like a dam, for example. If the dam doesn't exist, you will have a flow of the water with a velocity. This velocity is a vector field. In starting from the next video, we will deal with mathematical tools that show us how this interaction between scalar fields and vector fields occur